So for the past several weeks, we've been thinking about and learning how to make things and render them in Blender with the ultimate goal that we could go ahead and use those skills to make better visualizations of molecular structure. And when I say better visualizations, I mean comparing what we could get out of Blender, like what we'll see from today, versus what we get out of other programs, like say Avogadro, which is a pretty common program and which yields results like this, and which I think we're now situated to make something better out of. And so let's just dive right in. In order to make molecules in Blender, we're going to need a few things. First, we're going to need molecular coordinates that we can use to import where atoms and bonds are. Second, we're going to need some sort of ability to get those molecular coordinates in, and we'll use a plugin for this. And then third, we're going to need to understand how to manipulate the objects that we've gotten in, and that's what the past several weeks have been focused on, is preparing us to understand what we're looking at when we look at these structures in Blender. And so I think we already have the third one basically taken care of. We'll look at it in detail a little bit in this video, but let's just start with the first two. So what we're going to need then is to find molecular coordinates and then import them into Blender. In order to obtain coordinates, there's a couple different ways you could do it. You could go online and find coordinates. What we're going to do today, though, is we're going to generate them ourselves. And we're going to use, for this, a program called Avogadro, which you can download from this website. And what it allows you to do is to draw 3D representations of molecules, as well as do some simple manipulations of them. And then, of course, export them into the file structure that we want. When you open up Avogadro, you'll be greeted with a screen that looks a lot like this. You'll have a black background, and then you'll have a toolbar across the top. There's also a menu bar you can't see because of the vagaries of how I have to record this, and maybe that will be fixed in the future, but for right now you can't see the toolbar. I'll let you know when I'm using it up at the top. And so what we typically have are both tool settings and display settings that appear on the left, and that tells us how we're going to represent things in the display settings. And then the tool settings are for what we're working with across here, and what we're going to use across here is simply the draw tool, the navigation tool, and then the energy minimization tool or auto optimization tool. There's other tools that allow us to do things like move around individual atoms, but we won't need that for this tutorial. So let's start by drawing. We start under the tool settings. We can see with a hydrogen, we don't really want hydrogen, I want carbon. So you may have defaulted to carbon, I don't know. But if we click, we'll get a carbon atom. We automatically fill in the hydrogens, and so this is tetrahedral. One of the hydrogens is just behind it, and let's not worry about this right now. We need to draw a molecule. Let's pick something simple. I say something like phenol or something similar. I think phenol's probably fine. So why don't we just go ahead. I'm going to click on this hydrogen and drag over. You'll see it will have made that hydrogen a carbon. And so now I've got 3 carbons. I'm going to click on this and drag it 4 carbons, 5 carbons, 6 carbons. And then I can bring this over to close the ring. You'll see like it's a little interesting because you can see the overlap of this, and what you're trying to do is move it until you can't see that overlap anymore. There we go. It sort of clicks in when it's trying to draw this last bond. So now we have a 6-membered ring, and to that we need to draw an oxygen if we're going to have phenol. And so there's an oxygen. We have cyclohexane with an oxygen bound to it, and if we're going to have phenol, it needs to be aromatic. So how do we solve that? Well, we can just click on the bonds to make them into double or triple bonds, whatever we want. So if I click on this once, you'll see I get a double bond. If I click on it again, I'll get a triple bond. If I click on it again, I go back to a single bond. One thing to note is if you click too fast, that's a command that Avogadro uses to recenter your display. And so you need to actually sort of take your time depending on how you are trying to draw these. So let's go ahead and say here's a double bond, here's a double bond, here's a double bond. Now we have phenol. It just kind of looks crazy because we know this should be a 6-membered ring that is a hexagon, and what's going on is we've drawn like a highly non-optimized structure. And so in order to get it optimized, why don't we use this tool, auto optimization? If I click on this, then you'll see I have some options down here in the display settings. UFF is a fine force field. It's not like the best, but it's good enough for what we're going to do here. And so we're going to just take its steepest descent in order to get an optimized structure. If I click start, you'll see it happens pretty quick. It's running up here, and then when it stops, it means that it is optimized. And to me, that looks pretty reasonable. We expect this to be planar. We can't really see that it's planar. And so the way to see that is to go back to this over here, navigation tool. And you can see if it says under there that the left mouse button, I can click and drag to rotate the view. So let's select this and then just click and drag. And you can see, yes, this is planar. So now we have a molecule. We can try to make it look, it actually kind of looks okay. I can middle mouse scroll in order to make it look larger if I want. And then if I wanted to try to export this somehow in order to make it look nice, then what I would do is I would go to the File menu, which again you can't see, but if I click on File, I can say Export, and then I can go to Graphics, and it will bring up a dialog that looks like this, where it's saying export as a PNG. That's what we'll do because that's what we're going to export in Blender. If I go ahead and do this, I'll say phenol Avogadro 1, because we're going to export one more time after this. And let's just go ahead and put this in the downloads. Save. All right. The reason I want to export it one more time is that I can't make this transparent behind it, but I don't really oftentimes want a black background because a lot of times we're putting this into pages that are white. And so the way to solve this would be we go to the View menu, which is, if you're looking at your structure, you have Avogadro File, Edit, View, and then you say Set Background Color. This brings up a dialog that looks like this, and then you can just pick white. And this is maybe a little bit more something that's useful for us. So then let's go ahead and just export this one more time. Export graphics, that will bring up this, or I can export a PNG, and then we'll call this Avogadro phenol Avogadro, let's call it white. And then again, I can save this in the downloads file. Save. The picture's not really what we want though. We would like molecular coordinates. And so we need to save this in a way that we can see in Blender and import molecular coordinates in a meaningful way. So to do that, what we do is we go to File, Save As. And you can see that under this we have several options of file types. One is PDB, that stands for Protein Data Bank, which is the file that we use format for reporting protein structure. And it's also what we want to import into Blender. Blender will also recognize XYZ, which we have the ability to export, but the XYZ doesn't contain information about bonds, and I want to talk about bonds, so we use PDB, which does. So let's just go ahead and call this phenol, and then let's put it in the downloads section as PDB, and then just so I can show you what these formats are like, I'll say save as, and we'll save this as phenol XYZ also in the download file. So now we have our structures saved. We're going to import those into Blender, but let's have a look real quick at those file formats just so we understand what's going on in them. So to do that, we can bring up our file navigator, and then in our file navigator we see we have the phenol protein data bank and phenol XYZ. The protein data bank is the one we want to use. I'll open this with text edit. I'm using a Mac. If you're using Windows, you can use Notepad++, and if you don't have Notepad++, you should immediately go get it because it is the greatest text editor mankind has made to date. But I'm on a Mac, and so I have to, deal with this like peon sort of business over here. Okay, this is what the file looks like. You can see there's several rows. The rows have different leading names like compound, this is unnamed, author, generated by OpenBabel. Heteroatom is telling us that this is not part of a protein. If it was part of a protein, or if it thought it was, it would just say atom. Then you have connect, that describes the bonding. So the het atom tells us about our atoms. The atoms are numbered 1 through 13. There's 13 atoms. I have the name of the atom, which is different from the atom type or like what element it is. That's actually given over here at the end. So this is the name of the residue that it's on, because again, it's intended for proteins. This is the residue number. And then I have 3 columns here that give me the X, Y, and Z position of our atoms. Then I have the occupancy, because we're oftentimes describing crystallography. And so we have to know whether that's occupied all the time in that spot or not. And then we also have something that deals with the charges that may exist on this. The connect tells us the bonding. It tells us that atom 1 is bound to atom 2, 6, and 11. That atom 2 is bound to atom 1, 3, and 12. And so that's the format. The first one gives us the atom number, and then the next entries tell us what they're bound to. And if we look back at Avogadro, we can see that that's true. So under this display right now, we're at ball and stick. I can add in a label. And if I add in a label, then I'll see that atom 1 is bound to atom 2, 6, and 11. And then if we go back to the file that we were just looking at in text edit, then you'll see that atom 1 is bound to 2, 6, and 11. So that's how the structure and the bonding is recorded in the PDB. If we think about not the PDB but the XYZ, let's just have a quick look at that. Then we can see in the XYZ, it's much simpler. I just have 13 atoms. It tells me the energy that it thinks these atoms exist at, and then it just lists them by their element and then gives their X, Y, and Z coordinates. And that's it. So it's a simpler format, but it doesn't have the bonding information that the PDB does. One thing that I should also note about this PDB format is that the bonding, even though we do record what's connected to what, it doesn't record whether things are single, double, or triple bonds. So we're going to lose that information, and we're just going to have to live with that. All right, so once we have this structure encoded, we're ready to import it into Blender. And so then we can open up Blender. In Blender, we're of course always greeted with this splash screen. We're always greeted with a camera, a cube, and a light. We're not going to need those. We're not doing anything with them. So let's just go ahead and delete these. Now we're ready to import our file. Before we do that though, we need to ensure that we have the right plugin. So under Edit, Preferences, we look through our plugins for something called Atomic Blender. So Atomic Blender, you can see I already have it enabled. It has a check mark. If yours doesn't, check that. But also click on this arrow to see all the information below it, and make sure you also have the utility panel checked. It's not checked by default, but you will need this later on. Once we've enabled that plugin, we're ready to import. So let's go to Import Protein Data Bank. You can see that I have the XYZ in the Protein Data Bank, but we want to import the Protein Data Bank. And then we're greeted with something that says, okay, tell me what to import. So I put this into downloads, and we called this phenol.protein data bank. We have several options. Let's just go ahead and change 2 of them right now. One is the camera and the lamp. I would like to have a camera and a lamp both added this time. So let's just do that. Let's leave everything else as default for now. We'll come back and look through it. But let's just have a look at what this does once we add it. So, and you can see we're going to get our balls or atoms as NURBs, and we're going to get our bonds as dupliverts. And we'll talk about that in a moment. But let's just say import. Now here's our structure. What you can see is that this used to be blank over here, and now we have like just a lot of columns about information in our scene collection side of things. In fact, so much that I'm actually going to just kind of push this down a little bit so we can see more. I have also added in a camera and a light. And what the plugin attempts to do is put the camera in such a position that you can see everything, and put your light in such that it illuminates everything kind of off to a 45-degree angle. And again, the hotkey for cameras is 0 in your number pad. If you don't have a number pad, you can go to View Cameras, Viewpoint Camera. And there is the camera added in. We indeed can see everything. All right. So let's think a little bit about this structure. I'm going to hold the middle mouse button and rotate off, and then I can zoom in. And here is our structure. We have NURBs, right? I could also see what they look like under the render view if I want. I can't see many of the bonds. I can kind of see there's a little bit here, and that's because these balls are very large and they're running into one another. We'll talk about that. If I want to see the bonds, I could hide the balls, and if I click on the balls, you can see here's carbon mesh, and then I can click on this. It calls it a mesh even though it's a NURB. That's just how it's programmed. And if I click don't look at it, now I can see the bonding. I can do the same thing for this oxygen atom. Here, there's the oxygen mesh, and I can say, let's not look at that. Okay, so this is kind of it. We have the hydrogen still shown. To me, this actually looks kind of okay, except that we have these bonds aren't smooth. And maybe you kind of like the way that looks, maybe you don't. And of course, like the way that we would normally think about doing this is just to click on it and smooth it, but you can't really do it, and we'll talk about that in just a moment. First, what I want to do is go back and think about what else we could have done in terms of importing this. So let's go ahead and delete this whole molecule. As you can see, we have a collection. I've got the carbon atoms, the oxygen atoms, the hydrogen atoms. I can delete the whole thing by just selecting this, right-clicking, and say delete hierarchy. If you say delete, it actually won't do what you want it to do. It'll just delete like this exact thing here and put carbon, oxygen, hydrogen in its own collection, not inside of the phenol. So we have to say delete hierarchy, and then it's gone. Let's go back and say import again. Let's import a protein data bank. We're still importing the phenol. It remembers that. We don't need it to import a camera and a lamp. If we keep those two clicked, then what will happen is that it'll just keep adding cameras and lamps, and that's just clutters this whole scene collection area. What we want to do next is try to understand what these options let us do. We were having a type of ball here as NURBs. And so we could have also picked to have a metaball, and we remember those are the things that when they get close together, blend together. So if I had a metaball and import this, now they kind of all blend together. All right, but we don't really want that. Let's say file, import, and protein data bank. We could have also imported as a mesh. We're a little bit more familiar with meshes. It gives us a sphere, so we can control the azimuthal and zenith number of sections. And then for any of these, whether we picked NURBs or anything else, when we have those highlighted, we can't control these, but we can still control the scaling factor. And the reason we couldn't see the bonds before is because the balls were too big. So I find that something like 0.75 looks all right, at least to me. Meshes are really useful to use because we've learned a lot about how to control the properties of meshes. So let's just have a look at that real quick. Here now we have the balls that are meshes, and then we can still see the bonds that keep everything connected. We have the same collection here. All right, that looks pretty good. I'm going to undo it so that we can go back and say import protein data bank, and then talk about the bonds. The default is to have sticks for the bonds. If you unclick this, then you just don't have bonds anymore. Dupliverts means that you have one single bond that's then instanced everywhere. And that's actually also what's happening here when we have the meshes. So let's just go ahead and look at that real quick. Again, I said we can't just click on this and say shade smooth, it won't do anything. And that's because we've instanced everything, and we're not looking at the real object. Instead, we'd have to go in and find the real object in this hierarchy, but let's not worry about that quite yet. Instead, let's just go back and import so that we can see a few other things. We also could have had skin and normal. Let's look at normal first. What normal does is instead of taking one object and instancing it over and over again, it'll make every bond a real object. And so when I import this, now I have these, and each one I can select individually instead of selecting each one on its own. And under this, we now have a stick collection where it gives us every single stick on its own. All right, so that's one way that we can get all of these bonds on their own. We'll learn another way in just a moment. All right, but we don't want this either. I've done enough that clicking undo is not going to work great. I'm going to do this wrong for a second and say delete instead of delete hierarchy. And what you'll see is now I just have carbon, oxygen, hydrogen, and sticks as their own separate collection. So now I need to select all of these and say delete hierarchy to get rid of them. Okay, import. We're going to do 2 more imports here and then we'll be done exploring this. The other option for bonds is to use skin. And what skin does is it tries to do something a little bit like the metaballs do. It's going to blend all the bonds together. So when I import this, it kind of looks the same, doesn't it? But if I go in and I hide these carbon meshes, you'll see that instead we're left with a structure like this that looks, to me, a little funny. So I find myself not using this too much, actually, but it's good to know what it does. So we're not interested, I think, in that. And I would say, not always, but for most of us, and most of the time, the best is going to be just importing, not with the defaults, but with this as mesh and this as dupliverts. And when we have those 2 things done, then things work out pretty well, I think, in terms of manipulating the structure the way we might want to manipulate it. Okay, there's one other option here that we haven't talked about, which is color. And what happens in color is it means that the bonds are given the color of the atoms that they incorporate. And without using color, what you'll see is that if I hide the meshes, so let's hide these carbon meshes and these oxygen meshes, then we don't have the sticks indicating the color of the element anymore. Whereas when we do have color selected on our bonds, if I hide the carbon mesh and the oxygen mesh, you can see that we split the bond in half to indicate that there is an oxygen. Now, one thing you'll notice is that we do end up with a case that when we have something like this where there's only 2 bonds, you can see the end of this cylinder. And that's something we could think about worrying about or not, depending on how nice you want this thing to look. We're going to use with a ball and stick kind of representation. And so we can just keep these like we see here. Now, one thing is we have this, but it's not smooth. And I think most of us would like this to look smooth. And so what we can do is, click on this and shade smooth. We'll run into the same problem where like nothing happened. And why didn't it happen? It's because, again, we've used instancing. What has happened is that we've taken a single ball that's real, and then we've used something like the geometry nodes that we saw 2 videos ago to put balls at different positions or different vertices. And so what this plugin is really doing is it's reading the coordinate file and it's putting vertices at each coordinate. Then it's taking a ball for an atom type and then it's instancing it to those coordinates. If we want to change the behavior of this, we need to find the real ball. If I look through this here, we're in carbon, we have carbon atoms, carbon mesh. This carbon mesh is actually the duplicated ones or the instance ones, and that's why when I click on one of them and I select one of them, I actually got all 6. And they're all referring to a real one that's hidden under this down arrow. So if I go down to this carbon ball, this is the real one. And if I click show, you'll see here it is, right at the origin. All right, that's the one. If I click on this and say shade smooth, everything becomes shaded smooth. And then I can re-hide this if I want. And so in order to make everything shaded smooth, we just have to do that for everything. So here's the carbon atom, or the oxygen atom. I go down to the oxygen ball. That's a real one. I can show it, right click, shade smooth. Whoop, need to select it first, shade smooth, and then don't show it. Then we do the same for the hydrogen. There's the hydrogen atom, the hydrogen mesh. I click on it. There's the real hydrogen ball. There it is. I'll click on it and say shade smooth. So now all my atoms are shaded smooth. I probably want to do the same thing for the bonds. And so let's go ahead and hide this and think about what's happening there. The same thing, if I click on one of these bonds, you can see I'm getting them all. These are all the carbon stick meshes. And so just as before, you might imagine that under it are the real instances. And here we have 2, the cup and the cylinder. The cup is, you can see this like solid thing and it's really thin. So that's actually the cap, I would call it, right? On either end, you can see there's maybe here 2 of them. All right, That we don't need to be shaded smooth, actually. It's not going to do anything for us. What we need is a cylinder. And the cylinder is this like thin, narrow region here. And what is happening with this cylinder is it's being dupliverted over and over and over again, which is why we have all these slices. And I want all those slices to be shaded smooth. And there they go. So then I can hide this. And then I just have to do the same thing again. I go to show the oxygen. I can say shade, select it, shade smooth, and then hide it. And then I'll go to the hydrogen sticks, hydrogen cylinder, select it, say shade smooth. All right, at this point, now we have something that's starting to look pretty good, right? I have a molecule, everything's shaded smooth, it looks all right. You might think to yourself like, okay, oxygen's red and hydrogen's white, we're used to that. The carbon's kind of gray, but it's like such a weird light gray that maybe I don't like it. So you can just change the properties of this. One thing that's kind of interesting is that if I click on here and I want to change the properties of this, I'm gonna have the same problem because it's not the real instance. So if I want to change the properties of the carbon mesh, I don't have to see it this time, but I need to click on the carbon ball. The carbon ball also has all sorts of other properties like this. Here's carbon 4. Carbon 4 is the material that's applied to the real ball, which means it's being copied for every single one of these. So I can change that. I can just say the base color, I want my carbon to be a little bit darker gray. And now there you go, it's dark gray. You could change the hydrogen to be a different shade of white if you want, but to me this already looks like pretty reasonable for what we expect to see. All right, what else might we want to do? Well, we could do things like adjust the camera and the lighting. We already know how to do all that to make it look how we might want it to look. But one thing that might be nice is that we want to emphasize a particular atom. For instance, we're dealing with phenol here, which is electron donating, and we know that that's going to make the ortho and the para atoms a little bit differently reactive, with the para being the most reactive. So maybe I want to highlight that this carbon and this hydrogen are somehow different. I have a problem though, because if I click on this, then I select everything. I have no way to adjust this on its own. And I would like to somehow pull out this individual carbon and maybe this individual hydrogen here so that I could emphasize that they're somehow different. Okay? And a way to do that would be to select all the things I'm interested in pulling one out of and then go from object mode to edit mode. And now in edit mode, what I can do is select individual balls because they're actually individual spheres, or vertices, remember. And in edit mode, we have control over vertices. So I could try to click on one of these. It's going to be hard to know that you've selected it. So maybe a neat trick, which we're going to need to use anyway, is to go to this little arrow here on the side and pull it out. And then I can see transform, nothing selected. If I click here, now I've selected something. I could use this to move around. I can move vertices, right? So if I hit G, I can move this now around on its own. Whereas if I was back in object mode, I can't do that. If I try to move them around, I move all of them, all right? So edit mode is again how I get control over individual ones. Now you might think oh, that's great. I'll go in and I'll change. I should not have done that. Let me undo it. I can go in and change things like maybe its size and hit scale, and what you'll find is that it does nothing because you're scaling this individual point, and it's kind of meaningless. And I also can't use it to control its own material. Instead, I need to separate this out from everything else that's in that instanced collection. And so to do that, I need to access the utility panel that we enabled before, which is actually held under Create. So under Create, you'll see I have Atomic Blender Utilities. I had this atom selected, and with it selected, I can go in and say Separate. If I click Separate, now you'll see these 5 are selected. It's also moved us back to object mode, straight out of edit mode. And then I can select this on its own, or I can select the remaining 5 together. And that means I can now individually control the properties of this. You can also see that under carbon atom, it's given me a carbon ball separated. So that is this. And then what I could do is try to somehow indicate that it's different from the other carbon atoms. Maybe, for instance, under the materials properties for that carbon ball, I could say, I don't want carbon 4 anymore. I want a new material. So I'm going to say plus and new. So I have material 1. Let's call this para-carbon. That's the material that we are now applying here. And I can say, maybe what I want is to have some emission. Maybe this thing is like glowing. And I need to not have carbon 4 still applied to this material. So I'll say, get rid of this. You can see now that I have something that's like glowing, and I should not have done that first. So let me turn that down. It's the wrong color. So let's get a base color. Let me click on eyedropper and say, I'd like this color. So there we go. Now I have the same sort of gray, and I am going to make it emit. I turn this up a little bit. Maybe we make it like blue, like it's got extra electron. I don't know. Electricity is blue. Is that true? I don't know. But anyway, it's blue, glowing just a little bit. And then we do the same thing for this hydrogen. And so again, I want to separate it out. So I select all the hydrogens. I go to edit mode. Then I click on this to make sure I have the node that I want selected here. Then I say separate. Now all these hydrogens are separate. This are part of the collection. This one is separate. I can say I don't want this. I want a new material applied to this, which I'm going to call para-hydrogen. And then we do the same thing. It's got about the right color, but of course we can like make sure it's the right color by clicking on this. And then we can do the same thing where this is now going to emit some color, and that color that it's going to emit is maybe like a similar blue. And because it's emitting over white, you might have to play around a little bit to get it to look kind of the same. And you know, maybe that's where part of the fun comes in. I don't know. Maybe I have to turn this down to make it look a little bit more gray, and then I'd have to turn the emission strength up a little bit to make it look, or up or down to make it look right. But now we have something like this where it's glowing and it looks just a little bit different from the other ones. So that's an option for how you might want to like handle highlighting different aspects of a molecule once it's been imported. Of course, here we're simply trying to compare what we have to what we could have got out of Avogadro. So let's just go ahead and change these back. It's pretty easy. Here's the ball, the carbon ball. And what I do is I go to the materials tab and I say, actually, I changed my mind. I don't want this. I really want carbon 4 like we used to have. And then we do the same thing here where we say, all right, I don't want this para-hydrogen that I made. I would like to have hydrogen 4. And now we have something that looks normal. I can hit number pad 0 to look through the camera, and then I can think about if I wanted to render this. Now, of course, we can make the lighting better, and we have the ability to do that. We're not going to focus on that here. Instead, we're just going to render the basic image so that you can decide how you think it looks compared to what you would get basically out of Avogadro. We're going to learn one more thing. I'm going to say F12 just so we can see what happens. There is the rendered image. This is in EV. You could choose to use cycles if you want, but it's on this gray background. And one immediate advantage to using Blender is that I can actually make this transparent if I want. The way I make this transparent is to go to camera, and then under camera there is film. Under film I can say transparent, and that means there's no background anymore, so that when I hit F12 and render this, I just have this like gridded background that indicates that this is a PNG with no background. And then I can put this on a white background and get something that looks like we had in Avogadro, but of course I can also put it over the top of other things. And so that's what we'll go ahead and do. I'm going to say go ahead and save this image, and we'll call this Phenol Blender. And then the comparison between this and what we saw at the beginning is or between this and Avogadro is what we saw at the beginning of this talk. So with that, you have seen how to import into Blender using a PDB. We know how to do the basic manipulations of this structure when we import it and afterwards. And hopefully that should set us up to making molecules that look really nice by doing things like maybe changing the lighting and the camera angle around a little bit, maybe changing the properties of these materials around a little bit. And the next week, I'll take a more advanced example and show you sort of what I do and how I think through trying to make these things look nice. All right, so I'll see you next week, and I look forward to seeing the molecules that you all create.